Now let's look at the next example problem. This is a USICO problem called the dishwashing. So this is a 2019 gold level problem. It's fairly challenging, and it has some similarity with the homework problem working at the restaurant, but it's not. It has some similarity, but it's not. It's still fairly different. But it just all illustrates this stacks last in first out behavior. So here's the problem description. So we have Bessie and Elsie, who are the typical stars in USICO problems. They are washing dishes, and Bessie will apply soap, and Elsie will rinse. So the input is given to Bessie is a dirty stack of plates labeled 1 through n, and they're in arbitrary order, so they're not necessarily from 1 to n. And Elsie has an empty stack where the clean stacks will go. So then there's a counter in between Bessie and Elsie for soapy stacks, and you can put multiple stacks on this counter. So these counter are the intermediate things. So before the things are taken away and rinsed. So in each step, Bessie can take a plate from the top of the dirty stack, apply soap, and then place it on the counter. But we are restricted in how we can place on the counter. So when we place on the counter, Bessie either have to place the plate on top of an existing non-empty stack, or he will create a new stack that's to the right of all the existing soapy stack. So the order of the stacks matter because of Elsie's behavior. So when Elsie want to take plates to rinse, he will, she will always follow the same order. So she will take a plate from the top of the leftmost soapy stack. So that means once we have the stack there, when Elsie take it, she will always go through all the plate in the first stack from top to bottom, and then move on to the second, then move on to the third. So if Elsie wait until the end to take, then and we want to ensure that when the clean stacks are taken, they are taken in the order from small to large, which is specified on the next slides. So the goal is for all the clean stack, the single clean stack of plates, to have all the plates in order with the smallest on the bottom. So that's because we have to rinse the smallest one first and then put it down, so then it will be on bottom. So at any point, the multiple stacks of soapy plates, they should be follow the order from small to large on the first stack, and then small to large from the second, and so on. And they and the biggest one on the first stack should be biggest one would be the bottom one, should be less than the top one on the next stack, in order for this order to be preserved. So it may not be possible to handle all the plates so that they will be placed in order. So the question asks us to determine the length of the longest prefix of the input that for this goal is achievable. So this is the sample input. We have 5 in this order, and the output is 4. So again, I think this is a fairly challenging problem, and it's described the thing that's described is fairly complicated, so it requires a little bit of time to think it through. So I encourage you to pause, try to understand the problem better, and then try to work through this sample example and see why the answer is 4. So let's see how this sample example will be handled. So the first one is 4. So then it will be put on the first column, first stack. on the island in between them. So 4 will be here, and the next one is 5. So 5 cannot put on top of 4, so we need to then they will be taken out of order. So we put 5 on the next stack. So 5 will be bottom of the next stack, and then we have 2. So 2 must go on this first stack because otherwise they will be taken out of order. So we put 2 here. The next one is 3. So the question is, where should 3 go? So 3 cannot go on the first stack because then it will be, at least at this point, it cannot go on first because then it will be taken out of order. But it cannot go on the second stack either because then it will be taken after 4. So the only way to handle 3 is we have to take 2 out because 3 has to go on this stack. 4 is the bottom, so 3 has to go before 4. So 3 has to go on this stack. So then at this point, we have no choice but to take 2. But by taking 2, that means that we cannot handle 1 anymore because we've already taken 2. So anything less than 2 can no longer be handled. So the way this thing works is we delay taking things as much as possible, but when we have a plate that we need to put on a stack and the top of stack is less than it, then we have no choice but to pop those until we can put it on, at which point we can wait. So we should wait to take plate until as late as possible. Because there may be other things that are put on top, and then we can handle those if we wait. So long as we can wait, we can still put down the current plate without having to take something. We should wait, and once we start taking something, then any plate that we haven't seen, whose number is less than the largest plate we have taken, is doomed. We cannot handle that. So that's the idea. So we are going to need to use multiple stacks here, and then for each plate, based on its number, we need to figure out which stack it should go, and then based on the stack content, we can decide whether we need to take things out, and the number of this item compared with the largest thing we have taken out will decide whether we can still handle this plate. So anything already put down in the middle can be handled correctly. So because the way we put them down is only when we can take them out in order. So I think okay. So yeah. So this is the pretty much what I have described. So we use multiple stacks of plates as temporary storage, and every stack is in order, and the consecutive stacks are in order. And every plate, there's a single stack that it has to go to. So if it's bigger than anything we have seen, we can put it down at the new stack. And if item cannot be placed, we need to start taking place to enable putting this down. Yeah, whenever encounter a smaller plate, the new plate cannot be taken. Then we get the answer at that point. So even with this understanding how it's done, I think the coding is still a little bit complicated. The solution code on UserCode website, it's very succinct and fairly elegant to my taste. So I'm going to explain that next. But let's take a pause here.